So let's take a look at a couple review problems here for our test. Determine whether the given ordered pair is a solution of the system. Very simple. What's all we have to do here?
Substitute the x and y.
Substitute x and y. Good. Okay, plug them in. You have access to the Desmos Scientific for the entire test. You don't get the graphing until near the end, but you have the scientific calculator the whole time. So if you want to use that, you may. We could plug 1 in for x and -5 in for y in the first equation. And remember how we do that. When we're substituting, we plug the values in parentheses, right? So it looked just like this. 7 times 1 plus 5 times -5, and it tells us what the output is. It's -18, which matches the right side of the equation. So in this case, it works. Okay, that one checks out. How about the next equation? If I plug 1 in for x and -5 in for y, and I could just throw that into Desmos here, I get an output of 12, which is different than 10. And so that one doesn't match up. That one, it's the ordered pair is a solution of the first equation, so it's a point on that line, but it's not a solution of the second equation. So the point is not on that line. So is it a solution of the system? No. Has to work in both. Has to satisfy both equations in the system to work as a solution to the system. And then I included in the notes, this, if you want to get real nerdy with Desmos, there's another way you could use Desmos Scientific to check that a little more quickly. Okay, but that's totally unnecessary. If you want to, you can look in the notes and check that out, but I'm not gonna take time in class to show it to you. Okay, what about this? Now, first of all, notice I want to point something out. The questions are going to give you some bogus directions during the test. They're going to tell you, for the first part of the test, they're going to tell you to verify your work using a graphing calculator. Don't do that. That would pop up as cheating, right? That's because you can't use Desmos Graphing until you get to the end of the test. So ignore that. Now, how would we solve this? Substitution or elimination?
Substitution.
Substitution. Good. How come substitution, somebody?
Because it gives an x.
Okay, good. Okay, we have x isolated, right? Yes, sir?
They're written in 2 different ways.
Written in 2 different ways. And they've done some work for us here, haven't they? They've already isolated the x. Remember, substitution is the one that we use only when it's easy to isolate a variable, right? So in this case, already done. We'll put a box around that substitution equation, and we're going to plug that value of x into the other equation, right? We solve for the variable in one equation and substitute into the other equation, right? So we end up getting -7 times x. X is replaced with 4y plus 3 plus 6y equals -43, okay? And from here on out, it's a piece of cake. Now I've only got y's in that equation, so I can just distribute and simplify and solve for y. If I distribute the -7, I'm just going to get -28y minus 21 plus 6y equals -43. And I can combine like terms. -28y plus 6y is what? -22y. What do I do with 21?
Add both sides.
Okay, I'm going to add that over there, right? Push it to the other side. And then I'm going to end up getting, if I do that, -43 plus 21 works out to be -22. Okay, so Lucas, what's the value of y?
1.
1. Good. So we get y equals 1. Am I done?
No.
Not done. Damien, where do I go to find the value of x?
It's smaller equation.
Okay, back up to up here, right? Already got it boxed. So we'll just go right back to my boxed substitution equation to find the other variable. I'll plug in 1 for y, and I get x equals 4 times 1 plus 3, which is 7. And so my ordered pair then, my solution, is just 7, 1. Okay, good? No big deal. Okay, I'm going to skip up to a couple elimination problems. Let's look at some really easy ones first. Okay. Top one is super easy. Don't have to really do much at all. If I want to use elimination, raise hands. What would be my first step here? Let's hear from somebody else. Be brave. What's my first step here? Yes, sir. CJ.
Subtract 7x from 7x and make it 7x.
Okay, so
Or will you add?
I add them up, don't I? So I can add the two equations because I've already got it set up where I have opposite amounts of x's, right? My coefficients are opposite. So when I add those up, look what's going to happen here. Those guys are going to cancel, aren't they? They'll cancel out, and I'll just end up with 6y equals negative 48. So what's the value of y?
-8.
Negative 8. Good. If I just divide each side by 6. So there's half the battle. Now I can plug that into either equation. Let's go ahead and plug it in there, how about? Got slightly smaller numbers, I guess, in that equation. So if I plug it in there, I get negative 7x plus 2 times negative 8. I plugged in my value for y equals negative 37. So I get negative 7x. I'm going to have to add 16 to both sides to get rid of that. Everybody agree?
Yeah.
Okay. So if we add 16 to that side, I'm going to get negative 21, right? And so what's x then? Jack, what's x? 3. Okay, and we got our ordered pair then, 3, negative 8. Okay, so this one down here is almost as easy. What do I have to do here, though, to set this thing up? Do I want to use substitution here? Thumbs up, thumbs down, everybody. Thumbs down, right? Because there's no variable that's easy to isolate. I actually could use substitution if I divided both sides by 2 in the bottom equation. But we don't need to do that. We can just use elimination. Personally, I think elimination is always a little bit easier. Okay, Marissa, what am I going to have to do here? Do you see any way I could get either the x's or the y's to cancel? Any ideas? Peyton? This time I can't just add them up. I'm going to have to distribute something through an equation. What do you think, Charlie? Say it again, by how much? Okay, by 3 or negative 3, how about? Yeah, there you go, right? And what's the strategy? Well, that'd be, I can easily get the x's to cancel in this case if I just multiply everything in the bottom by negative 3. I'm going to end up with a 6x and a negative 6x. Would have been harder to do with the y's, wouldn't it? Because, 2 doesn't divide into 5 evenly, so x's are easier to eliminate here, aren't they? Okay, so how do we show that? Remember, if we leave an equation alone and we're not going to distribute anything, we're just going to give it a solid arrow. If I'm going to multiply by something, we'll make a bubble there, and that's going to be a negative 3. Okay, so the top equation stays the same. 6x minus 5y equals 19. I've got to distribute the negative 3 all the way through both sides, right? Don't forget the right side. Sometimes people do. So I get a negative 6x minus 6y equals negative 3 times negative 12 is positive 36. X's cancel, as advertised. That's good. And we end up with a negative 11y equals 55. Caden, what's the value of y?
It would be
Negative 5, good. And then I can plug that back into either equation. Let's go ahead, that's got small numbers in the bottom equation, so we'll plug it in there. And we get 2x plus 2 times my y value is negative 5 equals negative 12. I could just add 10 to the other side to get rid of that negative 10. So I've now got 2x equals negative 2 then, right, if I add 10 to both sides. And so what do we get for our value here? Tegan, what's my value of x? Negative 1, good. And my ordered pair then looks like negative 1, negative 5. Okay, so the hardest kind that we do here would be one like this. This is a little tougher because now I'm going to end up having to multiply both equations by something. Okay. Which one would you do? Well, it's almost a wash here. I mean, maybe the y's would be slightly easier. You could multiply by just a tiny bit smaller numbers. How am I going to get rid of the y's then? What would I have to multiply the top by and the bottom by to get those to disappear?
Multiply the top by 3 and multiply the bottom by 5.
Excellent, right? And then that's going to give me 15y and negative 15y. So those will cancel, and we'll eliminate y's and solve for x. Good. All right, so let's watch that happen. So top by 3, bottom by 5 gives us 12x plus 15y equals negative 33. Distribute 5 through the bottom. I get 25x minus 15y equals 5 times 10 is 50 plus 5 times 4 is 20, so that's 70. This time the y's cancel, and it looks like I get 37x equals 37. So x is 1. Plug that back into either one, we'll just go bottom. Five times 1 minus 3y equals 14. Subtract 5 from both sides. Negative 3y equals 9. So y equals negative 3. And we got our ordered pair, 1, negative 3. Good? Okay? Okay. Okay. Okay, graphing inequalities, no big deal. Remember, if I graph inequalities, I got to get a boundary line and a shaded region. So what's the boundary line going to look like for the top inequality?
Solid line.
Solid line. And kind of describe it, like use your arm and show me what it looks like. Okay, I'm seeing lots of these. Good. It's going to be vertical. It's going to cross the x-axis at negative 1. And am I going to shade, Marissa, am I shading, which side am I shading? Marissa, why don't you get rid of that? I think you got some distracting you there. Thank you. So where am I shading, left or right? I want the values of x that are greater than or equal to my boundary line. So I got to go right, don't I? Because the positive, bigger x values are to the right. So this one, that's what we're going to get, right? Okay. How about the bottom one? Boundary line. Okay, I'm seeing dashed, I'm seeing horizontal, crosses the y-axis at negative 5, shading below, yeah, right. Y values that are less than the boundary line. Y is my vertical variable. Less means below for y, greater means above, right? So we get something like that. Does everybody know how to get the dashed lines in the graphing tool?
Yeah.
Okay. All right. Graph a system of inequalities. All right, so I just graph these one at a time. Let's look at top one. We'll make maybe our red line. To graph that top one, what do I have to do first?
Get the y by itself.
Got to get the y by itself. Okay, so to get the y by itself, Kathleen, what's going to be my first step to get that y by itself in this equation? Good, subtract 3x. So first step, We're gonna take that 3x and push it to the other side. So we're gonna get 6y is less than or equal to, I got a negative 3x over there that I'm adding to the 6. Okay, next step, what's my next step gonna be, Nolan, to get that y by itself? Divide by 6. Good. So we're dividing both sides by 6. Rather than having a common denominator, I'll just break that up into separate fractions like we always do. And we end up with y by itself. Do I have to flip the inequality? No, how come? Oh, divided by positive, not negative. Good. Y is less than or equal to, I'll just look at the fraction in front of the x. What's that reduced to? Negative 1/2 x, good, plus 1. All right. Okay, so let's see here. Gavin, if I want to graph this boundary line, tell me how I'm going to graph that boundary line.
Go up 1 and then
Okay, there's my anchor point, good.
go back down 1 and over 2.
There you go, good. My slope triangle takes me down 1 over 2. So right there, solid or dash, everybody? Solid. Shading above or below? Good, below, good. And we know that because we know that y is supposed to be less than or equal to my boundary line, so we're shading down. And here we go. Okay, there's the first inequality. What about the second one? Okay, second one's a little bit easier to deal with, actually. What's the only step I need to get the y by itself there?
Minus 4x.
Subtract 4x. So we get that pretty simply then. We just get y is less than or equal to negative 4x plus 8. If I graph that one, how am I going to graph that one? Let's see, who haven't I picked on here? Kiefer, how am I going to graph the bottom one? Start at 8. And if my slope is negative 4, what am I doing there?
You go down 4 and then over 1.
Yeah, good. Because remember, I've got, anytime I have an integer, there's always a 1 on the bottom, right? If I want to think of it as a fraction. So I'm going down 4 over 1. Get a second point. Solid or dashed? Solid. Okay, shading above or below? Below, okay. And this is a little bit awkward here because it's a pretty steep line, but shading below, all I got to do to know where that is just start on the line and go straight down, and I'm in this half plane, obviously, right? Okay, so then here's the double shaded region, right? We can see that the boundary lines that define the overlapping region, we need to include those, so we'll make them purple. How about? There's one boundary, there's the other boundary, and everything in between gets shaded. There it is. Okay. And for our notes, there's what it looks like in, if you entered on the test or something, right? Do you guys get how to, what if I had both of these shaded and I wanted to get rid of that one? What would I do?
Click it, press delete.
There you go. You click it so that thing, I think it turns green. It highlights it, and then you hit delete, and it'll eliminate that region. Okay? 1 to 5. How are we doing? 7. All right, good. Okay, so now we're on to the part where we get to use Desmos Graphing. So this one couldn't be easier. All you're doing is graphing the two lines and finding the solution as the point of intersection, right? Now they do tell you here, you got to follow the directions on this. They tell you that they want the coordinates rounded to the second decimal place, so 2 decimal places. So what would my ordered pair look like then? What's the first coordinate rounded to 2 places? Negative 1.14. When would that move up to a 5? Oh, okay, if the next digit were 5 or greater, right? So how does that go? 5 or more?
Reads the score.
It,
4 or less, let it rest.
say it again. 5 or more, increase the score. 4 or less, let it rest. Okay, there you go. That's how I remember it. Okay. So negative 1.14, and then my second coordinate would be negative 3.57.
5-7.
Okay, no big deal, right? Okay, now a couple applications. These are the ones you probably, a question?
Yes, I've actually heard us saying, like, 5 and above, add 1.
Mhm.
4 and below, keep it low.
Okay. Well, we could do that too. I mean, I add 1 though. I don't know if I like that one because then it seems like you're, I don't know. But okay, I guess that works. Yeah, 5 and above, add 1. All right, take your pick. Take your pick. 6 of one, half a dozen the other. We like to provide many options in this room, so you get some choices. Okay, what about this one? An auditorium has 750 balcony seats and 1,900 main level seats. If tickets for balcony seats will cost 13 less than tickets for main level seats, what should the prices be for each type of ticket so that the total revenue from a sellout performance will be $88,300? So they're asking for the prices of the tickets. So those are our unknowns or our variables. We got to write that down. We'll call X the price of balcony seats. Y is going to be the ticket price of main level seats. So we got 2 unknowns. We need 2 equations in our system, right? Have to have as many equations as unknowns. So now we got to build those equations. Well, here's one part of it. If the tickets for the balcony seats will cost $13 less than tickets for main level seats, that's important information, right? If you can, see if you can always rephrase that using the word is or are or was or something like that, because then that turns into an equal sign, right? So couldn't we say something like balcony ticket price is 13 less than main level ticket price, right? And what's that turn into then? If I turn that sentence into symbols, balcony ticket, that's X. R, I guess maybe is, right? Balcony ticket is would be equals 13 less than main level. Well, isn't that just Y minus 13? Right? So there's my equation for that one. Okay, first equation. X equals Y minus 13. Good. Okay, second one. Total revenue from a sellout performance. Sellout performance means, skip phones away please. Sellout performance means all seats are sold. So how many balcony tickets are we selling? If it's a sellout? 750, right? How many main level? 1,900, okay? So how could I come up, I know that the total revenue, the total amount of money paid for tickets has to equal that number, right? How could I come up with that then? What do you think? Ron, what do we got?
750x plus 1,900 y would be equal to 88,300.
Okay, good, right? So the total money from the balcony seats plus the total money from the main level seats has to equal 88,300. And for the balcony seats, the way we're going to get that is 750 tickets. And if they each cost X dollars, right, every seat costs $8, then isn't that just 750X plus 1,900 main level seats times Y dollars per main level ticket, so 1,900Y would equal 88,300. Okay, so there's our second equation. Now the good news is, on all of these kinds of problems on the test, this is going to be the part where you can use Desmos Graphing. So all you have to do here is just graph those 2 equations and zoom out till you can see the intersection, right? And once I can see the intersection, that should tell me everything I need to know. So remembering that we defined X as the price of balcony seats and Y as the price of main level seats. And it's really important to write that down because it's easy to confuse yourself here, right? Like you could very easily get these backwards if you didn't have that written down, so you could look back on the paper and see that. then what's that telling us? What's going to be the price of balcony seats? Based on the graph. 24, right? Because that's the x coordinate, isn't it? So we get balcony seats are $24 a piece. Main level seats then are what?
37.
There you go, 37. And we're good, right? You guys need me?
Yeah, I think the rest of it.
Oh, Rissa.
Yeah.
Okay. Good? Questions? Give me 1 to 5 on that. How we doing? Okay. All right. How about another one of those? Scoot that out of here for a second. Okay, how about this one? A landscaper plans to dig a rectangular garden whose length is to be 2 feet more than the width. Okay? If the landscaper has 36 feet of fencing to enclose the garden, what should the dimensions of the garden be? Well, they're asking for dimensions, so our variables would just be width and length then, right? Dimensions of the rectangle would be width and length. We'll call x the width and y the length, how about? Okay? So we need 2 equations. What about this first one here? Length is 2 feet more than width. How am I going to write that as an equation? Length is, what's that look like? Length is what? How do we define length? Y. So y is, what's that mean? Equals 2 feet more than width. How am I going to say that? X plus 2, right? There you go. We got it. So there's first equation. Second equation. Now what about this one? The landscaper has 36 feet of fencing. Big deal. What's that mean? So what's that? What, in geometry, what would we have called that if it's a rectangular garden and the fencing is to enclose the outside of the garden? That's the perimeter, isn't it, right? And so we know the perimeter. Now the mistake people make with perimeter is they're going to say perimeter is x plus y. That's not right. What's perimeter? 2x plus 2y. How come? Because think about this now. Just like picture, whenever you think about perimeter, just picture a rectangle in your head. If that's x and that's y, to walk all the way around the garden, we got to walk x, y, another x, and another y. Got to walk 2 x's and 2 y's to get all the way around, right? So perimeter, 2x plus 2y, equals 36. There's my 2 equations. All I've got to do is graph the 2 equations, look for the point of intersection, and does everybody see that if x is the width, then the width is 8? If y is length, then the length is 10. Give me 1 to 5. Oh man, this is good. Okay, I like it. Is this ordered pair a solution of the inequality? Couldn't be easier. What do? Plug it in. If I plug it in, I can use Desmos Scientific, or on this one, I can't remember, maybe even have Desmos Graphing. But Scientific's probably easier. I'm just going to plug in the quantity, so in parentheses, 4/7 for x and 0 for y, and I end up with this number, 2.8, blah, blah, blah. Is that greater than 2? Yes or no? It is, right? So we got a true statement here. I get a number on the left that's greater than 2, and so the answer is yes, it is a solution. If I graphed it, all I would have to do is just graph the inequality in Desmos, and then graph the ordered pair, and we can see that the ordered pair is in the shaded region, and so yeah, it is a solution. Okay, but really I think this is even faster to do. Okay. All right, what about this one then? So this one, we're working backwards. This time you're given the graph and you have to write the inequality, right? So this isn't here yet. This is what you've got to come up with. So let's look at the steps required to get there. So first step is probably the boundary line, right? The boundary line, we can see that b is equal to 3, so that fills in the blue part, okay? We need m. And so if we look at a slope triangle between those 2 points, it looks like to get from there to there, we rise by -3 and run by 3. So my slope is -1, right? Okay, everybody good with that? So now we got the red part. I got mx plus b is -x plus 3. Okay? And then finally, it looks like we're shading, it's a solid boundary line. So I'm going to have an equal sign. And we're shading below, so that's going to have to be a less than. Y is going to have to be less than the boundary line, right? Everybody good with that? Okay. So that's our final step. If I put these in order, I guess it would go like this: step 1, step 2, step 3 in our notes. Okay, give me 1 to 5. You good with that? Okay. All right. And then last one, super easy. Last one, you get Desmos Graphing to do this. If I'm graphing this system, I'm just going to graph each inequality separately. Now, one thing you might want to do is you might want to make sure you've got 3 different colors so you can see the overlapping region better, right? How do I change the colors in Desmos? Do you know?
Click down on the color.
Click the gear, then I click on the dot and I can choose the color. Okay? Good?
Yeah.
I'm done. We're good. So I think I'll be gone this period tomorrow. I'm sure I will. Yeah, we're going to be on a basketball trip, so I'll have it set up so you guys can test tomorrow. It'll be a freebie test, but you can test in class tomorrow.